we are going to integrate tangent to a fourth power times secant to a sixth power. And now let's just stick with secant and tangent, and then let's think about strategy before we go. Ideally, we have to somehow try to cancel things out or try to substitution, right? And the idea is that if you want to use a u substitution, letting u is equal to tangent, then in that case, you better have a secant square somewhere. And we do have a chance to break this apart and then somehow squeeze out secant square. Here we have secant to a sixth power. Let's do that and hope for the best, and it will be the best. Anyways, this is going to be the integral of tangent to the fourth power x, but then for the secant to a sixth power, I'm going to break this apart as secant to the fourth power x times secant square x dx. Again, we can do this when we can squeeze out secant square and also there's a tangent involved. My ultimate goal is that u is equal to tangent and then the substitution will cancel out the secant square. But then I don't want to have too many secants to be dealing with. However, secant to a fourth power, I can replace this, okay? This right here, this is the same as saying secant square x raised to the second power, right? And then do we know anything about secant square? Yes, we do. Secant square is the same as tangent square x plus 1, okay? So once again, secant to a fourth power is the same as saying secant square x to the second power, and secant square is the same as tangent square plus 1. And now let's look at this. This is going to be the integral of tangent to the fourth power x times this from secant to the fourth power, and then times secant square x dx. Okay? We are going to focus on this, and as you can see, this part and that part has nothing but just tangent. And then if we let u is equal to tangent, this is going to work out very nicely, and we'll do it. So I will begin by saying that u equals to tangent x, so I get du, and that will be secant square x dx. And if you would like, you can isolate dx, which is going to be du over secant square, and this and that will cancel each other out. Let's take a look. Let me just bring it up right here. Now integral is going to be integral of tangent is going to be u. So we have polynomials now. U to the fourth power. And then this right here, we have the parentheses. Tangent square, tangent is u, so we have u square right here, plus 1. And then raised to the second power. And then the secant square x dx, you can also just use this if you would like. That's going to be du. Or if you would like, you can plug in du over secant square into dx, and then they will cancel each other out. Let me just write down du right here for you guys. Du is the same as secant square x dx. Just a direct replacement. This is still hard, but it's much simpler because this is hard in a way that's going to be slightly long. That's all. But it's totally doable, okay? So the way to do this is, of course, we have to do algebra now. This is u to the fourth power, and I have to multiply this out. If you multiply this out, you get u to the fourth power plus 2u squared plus 1 du. And then I will have to distribute the u to the fourth power. So this is the integral of u to the 4 plus 4, which is 8, plus 2u 4 plus 2, which is 6, plus u to the 4 times 1, which is u to the 4 du. And we are finally ready to integrate this. The integral of this is going to be 1 over 9, u to the 9th power. And then this is going to be plus 1, which is 7, divided by 7, we have 2 over 7, u to the 7th power, and this is going to be plus 1 over 5, u to the 5th power, okay? And then the final step is, all the u's, it's just nothing but tangent x. So we have the answer, 1 over 9 tangent to the 9th power x, plus 2 over 7 tangent to the 7th power x, plus 1 over 5 tangent to the 5th power x. And then we are done. So we put plus c and then box the answer and then run away.